Okay, welcome to lecture 20. So, we have been discussing about the Kepler's problem. So, we finished the parabolic orbit and then we have started with the elliptic orbit. So, we will continue with that, but before that we will take one small problem which is related to week 3 whatever the discussion we have been doing. So, let us look into this problem. So, here Earth's mean orbit mean heliocentric velocity it is a given, it is around 29.78 or the around 30 kilometers per second. Okay. So, Earth is moving around the sun around 30 kilometer per second. So, assume that meteors travel in parabolic heliocentric orbit. Heliocentric means moving about the sun. So, this is the sun and around that Earth is moving. So, this is your Earth, it is going here in this orbit. Okay. Your meteor it is coming from somewhere else and it is going in parabolic orbit. So, this is your parabolic orbit. So that the speed of approach of meteors toward the Earth lies between 12.3 kilometers and 1.9 kilometer per second. So, let us say that this parabolic orbit here in this case what I have shown there, this is the orbit of the Earth, and if your meteor it is coming about this orbit, okay, it is coming like this and going like this. Okay. So, this is going in a parabolic orbit and Earth is moving here in this orbit. So, once they come here, so at this point if it is lying exactly it is a trajectory lying such that it is going to hit the Earth. So, its velocity will be 71.9 kilometer per second if it is coming from this direction. On the other hand, if the Earth is going around like this, this is the sun, this is sun and this is your Earth and meteor is coming from this side. So, if meteor is going from this direction say and they are meeting here in this place, they are crossing each other here in this place. So, the Earth will go here and meteor will also go here. So, the velocity of approach will be here in that case 12.3 kilometers per second, this we have to show, and here in this case 70.1 kilometer per second. Okay. So, with this much of high velocity 71.9 kilometer per second, this is a very high velocity. Okay. This even it is a very high velocity, while the Earth is moving around the sun with 30 kilometer per second. So, you can see that if the Earth is impacted by the meteor, so what destruction will take place. So, we have to calculate this value that indeed this will be between these two values. So, it is not necessary that exactly here the this is crossing here in this point, we can consider it at any other point because we have to show it the range, and we can assume that it is such that here if they are in the same direction like if the Earth is coming from this direction and here at this point this meteor is coming from this direction and it is such that angle between them is 0. This angle say this is here if I write this as alpha. So, alpha equal to 0. So, that impact velocity will be 12.3. On the other hand, if the impact takes place, if the meteor is going from this place and here if it meets here in this place. So, it will be in opposite direction and then the impact velocity will be 71.9 kilometer per second. So, this we have to show and this is a very simple problem. So, but understanding it is required. Okay, so, we use the equation v equal to mu times 2 by r minus 1 by a under root. So, this is valid for all the time as we know that we have derived it from mu by r minus this equal to minus mu by 2 a. From here we have rearranged it and we got it. So, for the velocity of the earth and velocity of the meteor we can calculate from this place. For parabolic for meteor, first let us consider. In parabolic orbit, E equal to 1, okay, and therefore, V meteor we can write as mu times 2 by r, and E equal to infinity. So, 2 by r minus 1 by infinity under root. So, that becomes 2 mu by r under root, where r is the impact where it is taking place. It is taking place at the radius of the Earth's orbit. So, this is Earth orbit. So, instead of writing r e, we simply write it as r. So, this is the meteor velocity at that point. Okay. What will be the Earth's velocity in this? So, V Earth, again this is 2 mu times 2 r Earth divided by 1 minus a under root. Okay. And let us assume that, see, the eccentricity of the Earth orbit, E is the, we will write as the eccentricity of the Earth's orbit about the sun is E equal to 1 by 60 around. Okay. So, this we will assume to be 0. Okay. That means, we will assume this to be a circular orbit. So, if we assume it to be a circular orbit, so Earth's, this is simplification, Earth's orbit is circular. If we do that, that means r Earth will be equal to a, and therefore, which we know that r Earth, this will be L by 1 plus E cos theta. In the case of the if we assume it to be circular, so this E is equal to 0 in that case. So, therefore, R E becomes equal to L, okay, and this equal to A times 1 minus E square. Therefore, E equal to 0 and this gets reduced to A. So, therefore, we are writing here R E equal to A, and once you insert here in this point. So, this becomes mu 2 R E minus 1 by R E under root. So, this becomes mu by R E under root, which is the velocity in the circular orbit, as we know it is a very easy to calculate. So, velocity in the circular orbit for the earth, this is known, and for the meteor this is also known. So, now if we add them, so we get the impact when they are opposite to each other, and if we subtract, so we get the impact velocity when they are in the same direction. So, this is on subtraction and this is on addition. So, simply therefore, the velocity of approach this will be given by mu by R E under root plus mu by, now here in this case for the meteor we have written here 2 mu by r. So, this we need to reduce to, because the impact will take place at the radius of the earth orbit. So, therefore, we need to replace it by 2 mu by r e. So, therefore, here also we have to write it 2 mu by r e, and mu value for the sun it is a given, and therefore, we can calculate it. So, this is mu by r e under root and 1 plus under root 2. Another case, once they are in moving in opposite direction, so we have to subtract it. So, in that case the same velocity in the case of, so this is the maximum velocity of approach, and minimum velocity of approach will be minimum velocity of approach. This will be given by, because this quantity is larger. So, we put it first here minus mu by r e under root. So, this is mu by r e under root times root 2 minus 1. Now, mu by r e we have to compute and insert here in these two places, and we will get the result. So, mu by r e is given to be, in the problem itself it is stated, Earth's mean velocity is 29.78 kilometer per second. So, the things are given. So, this quantity is given to be 29.78 kilometers per second. Okay. Therefore, once we insert it, so this quantity 29.78 and root 2 minus 1, this yields you 12.33 kilometers per second, and if you insert here 29.78 into 1 plus root 2. So, you get the result 71.89 kilometers per second. So, this is the maximum velocity here, this is the maximum velocity of approach, and this becomes the minimum velocity of approach, CT of approach. So, you can see that using this simple principle what we have developed, we can work out the things which are of so immense importance, and many times you might have heard that NASA has predicted that this meteor is moving toward the earth, or some asteroid is moving toward the earth, and if it impacts, the whole earth will get destroyed. So, the reason is very simple, because of this high velocity, and from here you can calculate how much energy it will add if the mass of the meteor or the mass of the asteroid is known. Okay. So, the whole kinetic energy it is going to be imparted. So, while it reaches the earth and impacts it at such a high velocity, okay. So, energy will be enormous, and the whole earth will depending on the size, even the whole earth can get destroyed. Okay. So, we go to the Kepler's problem as we have been discussing earlier. So, we start with that. Okay. So, here now we have been discussing that inside the circle we took one ellipse, okay. We were discussing Kepler's problem here for the elliptical case. Okay, and this we have written as auxiliary circle or circumscribing circle, and this is our ellipse. This is the semi major axis of the ellipse. This is the center of the ellipse here. This is the center. Focus is lying somewhere here. Okay, and then what we did that I will shift little bit focus on the left hand side to make it more convenient. So, I will write here the focus is F is located here. So, thereafter we extended this upward from here a vertical, this is 90 degree here. Okay, sorry, I have to revise this. First we draw the radius vector, and from there we have to extend. So, first we draw the radius vector. We from there first we took the radius vector to any point, and this we noted as P, this point. Okay. And thereafter we dropped a perpendicular from this point on the x axis. So, this is the perpendicular here. This angle we have written as theta. So, this is theta, and then this was extended up. Okay. So, this was extended up. So, this point we have written as m and this point we have written as n, and also we joined the point C and M. So, because distance between this and this point, this is A, means the radius of the circle, the auxiliary circle radius equal to A, and semi major axis is also A. This is also A, and therefore, this quantity is A, and m n then we have written as A, and this angle we have taken as E, which we have written as eccentric anomaly. So, m n equal to A sin E, and P n this we have written as R, because P f equal to R, P f equal to R. So, P n this becomes equal to R sin theta, okay. And similarly, f n this is nothing but x and this is nothing but y, the coordinate of P. So, the P has coordinates x, y. Okay. So, f n this is r cos theta. So, this we have written. Thereafter, we have utilized one property of the ellipse, that m n divided by P n this equal to A by B. Okay, so, from this place m n becomes, m n is nothing but A sin E, and P n is r sin theta. So, we are going to get relationship between them. So, this we have been working with that. Sorry, P n is r sin theta. So, this relation we have been working out. So, now writing the whole thing. So, the distance f n we have written, this is your coordinate from here to here, this you are writing as x from this point to this point, from f to this point, and x equal to r cos theta, as we have written earlier. This will be equal to A cos E minus A E. A cos E is what distance? This distance is up to this point, because this is the radius here of this point, this is A. So, therefore, this becomes A cos E, and distance between this and this is your A E. Okay. So, we are subtracting to get x. Okay. So, also x can be written as x equal to r cos theta equal to A cos E minus E equal to A common taking cos E minus E. And y equal to, already we have written r sin theta. Okay. And for that we use this ratio equation. So, in this case P n is your y, this quantity is nothing but your y. So, y equal to r sin theta, and we use this relationship this equal to P n and P n equal to B by see the M n by P n, this equal to A by B we have written. So, therefore, P n equal to B by A M n, and M n is nothing but B by A M n if we go back. So, this is the distance from this place to this place, M n is A sin E. So, already we have written here in this place. So, this equation just we are rearranging. So, this is A sin E. See, there is a difference between this R, R always we measure from this point. Okay. R is always measured from the focus, where R is the any point on the ellipse, while the radius of the earth is being indicated by distance from this point to this point, or either the distance between this point to this point. So, this is the radius of the earth. Okay. So, you have to be careful about this. So, getting this is B sin E. So, P n equal to B sin E. So, what we get from here, y equal to r sin theta equal to B sin E. So, this is the same thing here. From here also we could have written r sin theta equal to A by A times B sin E to B sin E. Okay. So, till this extent perhaps we did last time. So, now we have these two equations where x and y these are given. Let us say this is equation number 1 and this is equation number 2. Therefore, if we add a square and add them, so this gives us r square sin square theta. This becomes the cos square theta. The first term is related to x is cos square theta. So, we put here the cos square theta, and related to the y this is the sin square theta. So, we will put here sin square theta, and then squaring the other terms on the right hand side, adding them cos E minus E whole square plus B sin E. So, this implies r square equal to A square cos E minus E square plus whatever we are working now. So, this we are doing by one method, which is totally mathematical in nature, little bit of this geometrical relationship we have used here. Later on we will do it by graphical method also, because it is very important to do by graphical method, understanding the things, the basic principles involved. So, the next step is to expand them. So, this becomes cos square E minus 2 E cos E plus E square, and B square, because B is written as B equal to A times 1 minus E square under root A times 1 minus E square under root. So, therefore, B square will be A square times 1 minus E square sin square E. So, A square we can take it outside, and rest of the things we can work out. So, this is cos square E 2 E cos E plus E square plus sin square E minus E square sin square. So, now the term cos square E sin square E, this added together, that becomes 1. So, we write here 1, okay. And then rest of the terms we have to write here. This term and this term combined together. So, E square can be taken outside and we can write here plus E square 1 minus sin square E. So, that becomes cos square E. One step I am skipping. Yeah, okay, here I will write here E square minus E square sin square E, this equal to E square times 1 minus sin square E, this equal to E square cos square E. So, this I have written here in this place. Okay, so, this term and this term they are taken care of. The last term is remaining is minus 2 E cos E. So, this minus 2 E cos E, and if you can see that this is nothing but 1 minus E cos E whole square. So, therefore, R becomes equal to, because R is always a positive quantity. So, this becomes A times 1 minus E cos E. So, this is the R. So, this will write as equation number 3. Okay, now we have to get the theta also. So, what we are trying to do, as I told you in the last lecture, that while we were working with this equation r square theta dot equal to h. So, this we then wrote as d theta by dt equal to h by r square, and d theta r square divided by h equal to dt, and this we integrated to get to t minus t equal to r square divided by h d theta. So, here r and theta we are trying to, because it is not comfortable to work with the terms like L by 1 plus e cos theta, because r equal to L by 1 plus e cos theta, and then here we have 1 by h and theta 1 theta 2 integrating between theta and theta 2, this is d theta. So, this was not comfortable situation. So, we are converting into a form where we can easily integrate it, but such a long process of integration can be avoided if we use little the geometric property and graphical method. So, that I will show you later on, but this is also very useful while working with many problems. So, therefore, we are discussing this. So, next we have to determine this cos theta. So, cos theta, already the equations are known to us, the x value we are aware of. So, from there we can extract. So, r cos theta, here cos theta is given by this a times cos e minus e, r cos theta equal to a times cos e minus e, and therefore, cos theta that becomes a by r cos e minus e. So, this is our cos theta, cos e minus e A cancels out. So, we will eliminate A from this place. Okay, but still we have a form with which it is difficult to work. We have to eliminate here, see the r, if we replace in terms of this, and then cos theta we also require here d theta, okay, and we require it in a proper format. Okay. So, for that we need to work little bit more. So, this cos theta, this equation is rewritten as, rewrite this as 1 minus tan square theta by 2 divided by 1 plus tan square theta by 2. So, we are using this trigonometric identity, okay, and this equal to cos E minus E by 1 minus E cos E. Okay. Now, using componendo dividendo, okay. So, we write this as 1 minus, simply we have to add the denominator into the numerator and so on the left and right hand side. There are various ways of doing this. So, the first term we add it 1 by tan square theta by 2, you might be aware of this, there is nothing in this. If you are not aware of, just look into the higher algebra by Hall and Knight, tan square theta by 2, and then we subtract this term also, minus 1 minus tan square theta by 2. So, this subtracting this gets plus, equally what you can do, that first we instead of adding here, this we can do the subtraction, and this place we can see what I mean. Most of you might be aware of this principle, there is nothing great in this. See, the principle, it goes like this. If we have A by B equal to C by D, so we can write as, say, the B plus A divided by B minus A equal to D plus C minus D minus C, and equally we can also write as, the same thing can also be written as A minus B divided by A plus B equal to C minus D divided by C plus D. So, there is nothing peculiar in this. This is a very simple relationship which is used quite often. So, you will see that this is just exchange of numerator and denominator. This is A minus B, if you bring it on this side. So, this is A minus B times C plus D. So, A minus B and C plus D is there. So, here the sign reversal will take place. So, both are the same thing. So, the same principle we are using here, and if we do that, so we get the result 1 minus 1 plus tan square theta by 2. It is a matter of convenience, which one we either we can use this or either we can use it, both are same. So, it is nothing different. Okay. So, here we subtract here in this case, so that if we subtract, if we take this first and subtract from this particular term. So, tan will add in the numerator. Okay. So, this way we will have here tan square theta by 2, tan square theta by 2 divided by 1 plus tan square theta by 2 plus square theta by 2. So, once we have subtracted in the numerator, in the denominator we will add. So, this becomes then 1 minus tan square theta by 2, and similarly on the right hand side 1 minus cos E, 1 minus E cos E minus cos E plus E, and divided by 1 minus E cos E plus cos E minus E. So, here on the left hand side what we see that these two cancel out, these two add up, okay. This and this term they add up, and here these two terms they cancel out. Okay. So, we write it on the next page. So, this becomes 2 tan square theta by 2, and from the this position, okay. So, 2 tan square theta by 2 divided by 2 on the left hand side, and on the right hand side we have, as we can see from this place, this is 1 minus E cos E, we will write the whole term there, 1 minus E cos E and thereafter we have minus cos E plus E, and the other term is 1 minus E cos E, and then cos E minus E. So, this is the term. So, these two will cancel out, will drop out. So, that gives us tan square theta by 2, and here we have to rearrange it in a proper way to solve it. So, this will become 1 plus E minus cos E, we will take it outside. So, this becomes 1 plus E cos E, and similarly here in this place this is minus 1 minus E, and in this place we get it as 1 plus E, this is 1 minus E, this term and this term we are taking. So, once we take the, okay, we will rearrange it, because depending on minus or the plus sign outside, the sign will depend. So, 1 minus E cos E we are taking, if we write it with a plus sign. So, the 1 can be here in this place, and then we will get is minus E cos E. If we write here a minus sign, so this thing will change, but we want to put it here in this the same format. So, as it appears from here, this becomes 1 plus E divided by 1 minus E, 1 minus cos E divided by 1 plus cos E. So, tan square theta by 2, and this becomes 2 sin square E by 2 using this trigonometric identity, cos square E by 2 okay, and this implies tan theta by 2, this equal to 1 plus E by 1 minus E tan E by 2. So, we have taken only the positive sign. So, we stop here and we will continue with the same point in the next lecture.